For number 3, we've got a 5th degree polynomial this time. So since 5 is odd instead of even, the shape is going to be a little different than in numbers 1 and 2. But we can go ahead and plug in numbers. So when you plug in -2, you multiply it by itself 5 times. Since you're doing it an odd number of times, it'll come out negative. And then 2 to the 5th is 32. We saw 2 to the 4th was 16, and 16 times 2 is 32. Plug in -1, raise that to the 5th power, you get back -1. And the -1/2 this time, the negative stays, but you're going to have 1 to the 5th over 2 to the 5th. So you get 1 over 32. And the rest of the table looks like this. So now when we go to sketch this thing, the y values go up to 32, down to -32. So if you think about it from here, if you pay attention to the positive x values, they spit out positive y values, and the negative x values spit out negative y values. And again, for the scaling system, just choose something that's convenient to sketch. It doesn't have to be perfect, but it needs to be believable. It needs to make sense. There's the first point, -2, -32. -1, -1. And we hit the origin, and then I start to make a mistake right here. I put a point at 1/2, -1 over 32 and 1, -1. But those y values should be positive. So I'm going to go back and scratch those out. And I need to move those points up to the positive y values. And so you can see we get a different shape than what we got last time for numbers 1 and 2. But there is a similarity. On the right side of the graph, it looks a lot like the positive x to the 4th, like an upward opening parabola. But then on the left side, instead of coming up like a parabola, it's like you're taking the left side and bending it down. So you could call this a twisted parabola. It's like x cubed. But I'll call it an odd degree polynomial because all odd degree polynomials will have this type of shape where either you're coming up from left to right and there may be a little waviness in the middle, or you're coming down from left to right with possibly some waviness. Whereas if the highest power was even, then it would have to open either completely up or completely down. I'll also call this a running man because of the arms. It looks like an arm going up and an arm going down. As you go out to the right, the y's increase. Out to the left, they decrease.